Hey guys, so here's part 2 of the 3.2 day 2 notes. So sometimes neither of the variables in a system of equations can be eliminated by just simply adding or subtracting. In this case, another method is to multiply either one or both equations by some number so that adding or subtracting eliminates one of the variables, okay? Now, once again, when we do this, you get to decide which variable do you want to eliminate, okay? And I would always say go for the easiest one to eliminate, okay? So that means you only need to multiply one of the equations so you can eliminate something, then go ahead and do so. Okay, well, let's go ahead. Let's look at our next example. We have 3x plus 5y equals negative 9 and 6x plus y equals 9, okay? So here, notice that none of the variables have the same coefficient. So we need to figure out first, what do we want to eliminate? Well, here, I'm going to go ahead and eliminate the x. Because we've done a lot with eliminating the y's, I want to now try to eliminate the x, okay? If you want to eliminate the y, go ahead, and we should get the same answer. If not, recheck your work, okay? So that's what I'm going to do, eliminate the y, x first. Okay, now in order to do that, I have to have the same number. Now we need to think 3 and 6. What is the smallest number that they both can go into? Well, the smallest number they both can go into is actually 6. So we need to think 3 times what gives us 6? That's going to be a 2, okay? Now I need to multiply that 2 and multiply it by each term in that equation. Now I know 6 times 1 gives me 6. So I really don't need to multiply the second equation to solve here. So that makes it nice and easy, okay? So I do, in my first equation, 2 times 3x to give me 6x. Then 2 times the 5y to give me plus 10y. And then negative 9 times 2 to give me negative 18. On the bottom, it stays exactly the same, okay? Now our next thing we need to decide, are we going to add or subtract? Remember, we add when the signs are different. So you have a positive and a negative. We add or we subtract when the signs are exactly the same. So either they're both positives or both negatives. Well, notice our 6x, they're both positive. So we do need to subtract here, okay? So what happens is that our x eliminates. Now be careful, make sure you're subtracting and not adding. So I do 10y minus y to give me now 9y. And I do negative 18 minus 9 to give me negative 27, okay? So be really, really careful when you're doing those negatives there, okay? So now, from here, what I'm going to do, I am going to divide, okay? So when I do that, looks like I get y equals, and it looks like negative 3 there, okay? Okay, so I get negative 3. Excuse me. Okay, so now what I need to do is figure out, well, what's the x value? To do that, I need to take my y equals negative 3 and plug it into one of the equations. Now, it doesn't matter which one. I would say plug it into the one that's the easiest. I think the 6x plus y equals 9 is going to be the easiest one for us. So I have that. I'm going to just rewrite it. I plug negative 3 into there. So I have a plus negative 3, or let's do minus. We will have to move it over. There we go. Okay, now solving for x, I add 3 to both sides. I get 6x equals 12. Divide both sides by 6, I get x equals 2. Now I need to write my final answer as an ordered pair. Don't forget, when you write it as an ordered pair, x comes first, so the 2 comes first, and I have negative 3. And so that would be my solution there, okay? Okay, now let's go ahead and do the next one. What I would like you to do is go ahead and pause the video and try the next example on your own. Okay, let's see what you did. Now, some of you might have gone rid of the x's, or some of you might get rid of the y's. I'm going to go ahead and get rid of the y's. just because I think I can do that by multiplying just one equation instead of both equations. I always want to do the easiest thing imaginable, right? I don't want to do a lot. Okay, so to eliminate the y's, because I do notice that my coefficients, so 8 and 2, they are not the same number. But let's think about the smallest number that 2 and 8 can go into. Well, the smallest number is going to be 8. So the top equation, I don't need to multiply that by anything because my y already has an 8 in front of it. So I have 7x plus 8y equals 23. But on the bottom, I will need to multiply. Well, 2 times 4 gives us 8. That's going to be 4. Okay? Now I'm going to multiply the 4 by everything in this equation. So I do 4 times 3x to give me 12x. And then 4 times negative 2y gives me negative 8y. And then 4 times negative 1 gives me negative 4. Okay? Now I need to decide, am I going to add or subtract? Remember, if you have the different signs, so one is a plus, one's a minus, you add. If they are the same exact signs, so both positive or both negative, you subtract. In this case, we do have different signs. We have a positive 8 and a minus 8, so I'm going to add. So I do 7x plus 12x, that's going to give me 19x. I know my y's cancel out because that's the one I'm trying to eliminate. And then I do 23 plus a negative 4. That's going to give me 19 as well. So I divide both sides by 19. I get x equals 1. Now I'm going to plug that into one of my equations. It doesn't matter which one. I would say go for the easiest. And I think the easiest to plug it back into is going to be that 3x minus 2y equals negative 1. So I have 3 times 1 equals negative, 3 times 1 minus 2y equals negative 1. So I get 3 minus 2y equals negative 1. I'm going to subtract 3 from both sides. I get negative 2y equals negative 1. Bring this up here. So I have room. So now from here, I divide both sides by negative 2. Oops, sorry, that should be negative 4. Excuse me. So make sure negative 3, negative 1, that gives us negative 4. There we go. So I divide both sides by negative 2, so I get y equals 2. Okay. So now I need to write this as an ordered pair. So my answer is 1, 2. There we go. Okay. Okay, make sure you watch the last part of this video. We're just going to continue using elimination to solve systems of linear equations.